Welcome to A-Level and UP Physics. In today's lesson, we will discuss some important past paper questions on waves from May-June 2022, Paper 1, Variant 1. In this lesson, we will discuss these questions in detail so you can have clear understanding of these questions and also you can improve your conceptual understanding of this topic. Let's study together, let's improve together. For question number 21, it is given to us the graph shows the variation with time of the displacement of a particle as a progressive wave passes. We need to find out what are the frequency and amplitude of the wave. This question is pretty straightforward one. In this case, you can see on y-axis we have displacement. So it means the maximum displacement that is equal to amplitude. Maximum displacement is equal to amplitude. So simply we can write on here amplitude is maximum displacement. Amplitude is equal to maximum displacement. So the amplitude is equal to 5 millimeters. Now we need to find out frequency, but we can find out time period from here. Time taken to complete one cycle, or we can say time taken for one wave to pass through a point. That time taken is one time period. So in this case, this is one time period. So in this case, t is equal to 10 nanoseconds. So simply we can say 10 times 10 to negative 9 seconds. Simply we can say this is 10 to negative 8 seconds. We need to find frequency. So simply we can write down frequency is equal to 1 over time period. So we can write down 1 over 10 to negative 8. So it simply means that this is 10 to 8 hertz. Or we can write down this is 100 times 10 to 6 hertz, and 10 to 6 is equal to mega. So it simply means that frequency is equal to 100 megahertz. So the answer for this question is A. So pretty straightforward question. You need to understand what is amplitude and what is frequency and how to read from displacement time graph. So pretty straightforward one. So the answer for this question is A. For question number 22, it is given to us the graph shows the variation of the displacement of an air particle with time as a sound wave passes through air. The intensity of the sound is halved and the frequency remains constant. The four graphs below are drawn to the same scale as the graph above. Which graph shows the displacement of the air particle? Let's assume that initial intensity I1 is equal to I0 and initial amplitude A1 is equal to A0. But A0 we can read from here. In this case, you can see the initial amplitude of the wave is equal to 4 boxes. So simply we can write down this is equal to 4 small boxes. We can also assume the second intensity, or we can say the final intensity I0. I0 is equal to I0 by 2. So we can find out value of final amplitude. We also understand intensity is directly proportional to amplitude square. So we can simply say I1 over A1 square. This one will be equal to I2 over A2 square. In this case, we need to find out A2. So we can rearrange this one. We can write down A2 square. In this case will be equal to I2 times A1 square divided by I1. I2 is equal to I0 by 2 multiply by A1, and A1 is equal to 4 boxes. So we can say this is equal to 4 boxes square. 4 boxes square divided by, we have intensity 1 that is equal to I0. So we can simplify this one. So in this case we will get this is I0 divided by 2 times I0 multiply with 16. So we can cancel I0 with I0, and if we cancel 16 with 2 we will get 8, and this is A2 square. But we need to find out we need to find out a2. So simply a2 is equal to root of 8, or simply we can say this one will be equal to 2.8. so the amplitude is equal to 2.8 boxes. 2.8 boxes. And now we can check different waves and we can find the answer. In this case, frequency is the same, so time period is the same. So if you look at first one, in this case its amplitude is equal to 4 boxes, so this is not possible answer. If you look at this one, this has different time period and this also has different time period, so this is not possible, this is also not possible, because frequency remains same, it means time period also remains same. So A and B, they are not possible answers. But if you look at C, so in this case you can see the time period is equal to 4 boxes and this time period is also equal to 4 boxes, so this can be the answer. But amplitude of this one is not equal to 2.8 boxes, so this is only equal to 2 boxes, so this answer is not possible. But if you look at this now, in this case the time period is equal to 4 boxes and amplitude of this one is equal to about 2.8 boxes, so this one is the best possible answer. So this is how you can approach this problem. Simply you need to understand intensity is directly proportional to amplitude square. Then as I is directly proportional to amplitude square, it means you can write down I is equal to k times a square. So the ratio between intensity and amplitude square, this is equal to constant, and this is true for both waves. So that's the reason we have written I1 over A1 square is equal to I2 over A2 square, and then we can simplify and we can find value of A2. So this approach is very common approach. You need to understand how to use this approach. For this question, we need to find out which statement is correct. For option A, it is given to us gases cannot transmit longitudinal waves. This one is incorrect, because longitudinal waves are mechanical waves and they need medium to travel and they can pass through gases. So option A is incorrect. For option B, it is given to us longitudinal sound waves cannot form stationary waves. This option is also incorrect, because sound waves, they can form stationary waves. As we see the waves in organ pipes, those waves are examples of stationary waves. So option B is incorrect. Solids can transmit both transverse and longitudinal waves. This is true, because if transverse waves and longitudinal waves, they are mechanical waves, they need medium to travel, so they can pass through solids. So option C is correct. Option D, transverse waves cannot pass through a vacuum. As in case of electromagnetic waves, all electromagnetic waves, they are transverse waves and they can pass through vacuum and they do not need medium to travel. So the option D is incorrect. Electromagnetic waves, they can pass through vacuum. So D is also incorrect. So A is incorrect, B is incorrect, D is also incorrect. So the answer for this question is C. For question number 24, it is given to us a car is traveling at a constant velocity directly towards a man standing in the middle of the road. The driver sounds the car's horn as a warning. The horn emits a sound wave of constant frequency. The frequency of the sound heard by the man is different from the frequency of the sound emitted by the horn. We need to find out which statement is correct. First of all, let's try to sketch. Imagine that this is the car and this car is moving to the right with constant velocity, and this car produces sound with certain frequency fs, and there is a person who is standing right in front of the car. Let's say this observer is at rest, mean person is not moving. As this car is approaching, so in this case you need to understand car is approaching. It is given to us it is moving directly towards the person. So car is approaching observer. If the car is approaching observer, observed frequency of the sound by this person, observed frequency will be greater than frequency of the sound produced by a source. Now we also need to understand V means the speed of the wave in the medium. It will not change because medium is the same, type of wave is the same. So it means speed will remain constant. So speed remains constant, and speed is equal to f times lambda. If f increase, it means lambda will decrease. So simply we can say in this case, lambda observed, this will be smaller than lambda of the source, means lambda of wave produced by the source. Now we have understanding of these two things, mean how frequency will change and how lambda observed will change. So we can find the answer. The frequency of the sound emitted by the horn is greater. This one is wrong because this frequency will be lower. So this one is wrong. So option A is not correct answer. The frequency of the sound heard by the man depends on the distance. It does not depend on distance. It depends on speed of the wave, and also it depends on speed of the source. So observed frequency, this depends on speed of the wave, and it depends on speed of the source. When it is approaching, so you have to use minus sign. So speed of the source, and it depends on frequency of the source. So B is also incorrect. The sound waves continually accelerate as they move from the horn to the man. Speed of the wave does not change. If type of wave is the same, medium is the same, speed of wave will not change. So C is also incorrect. The wavelength of the sound heard by the man is less than wavelength of the sound emitted by the horn. So this one is true. So the answer for this question is D. So D is correct answer. For question number 25, we need to find out which statement about electromagnetic waves is correct. For option A, it is given to us a wave of wavelength 5.0 times 10 to minus 6 meters is invisible to human eyes. In order to decide whether we can see this wavelength or not, we need to understand visible part of electromagnetic spectrum. Visible part of electromagnetic spectrum is visible to human eyes. Visible light, so simply we can say visible light, means the light can be seen by human beings. The range of visible light is from 400 nanometer to 700 nanometers. We can convert this one into meters, so this will be equal to 4.0 times 10 to minus 7 meters, and this one will be equal to 7.0 times 10 to minus 7 meters. But now if we compare this one with the given wavelength, this has power 10 to minus 6. So this wavelength is longer than the visible part of electromagnetic spectrum. So we cannot see that. We can only see this range of wavelengths that is visible to human eyes, but we cannot see if the wavelength of the wave is shorter than this given range or if it is longer than this given range. We cannot see that wave. So in this case, this wavelength is greater than this given wavelength, means the given wavelength is greater than the visible part of electromagnetic spectrum, so we cannot see this wave. So this option is correct. They can all travel at different speeds in free space. This one is wrong. All electromagnetic waves, they have the same speed in vacuum, or we can say in free space. So different, this means this one is incorrect. So option B is incorrect. If this was same, then this option is correct. They cannot be polarized. All electromagnetic waves, they can be polarized. So EM waves can be polarized. So this is also incorrect. They consist of vibrating atoms? No. They consist of oscillating electric and magnetic fields. But vibrating atoms, they can produce EM waves. So we can say vibrating atoms can produce EM waves. But EM waves do not consist of vibrating atoms. They consist of, we can say, EM waves, they consist of oscillating electric and magnetic field. So you need to understand the difference. Oscillating E field means electric field, and B field, magnetic field. So they consist of oscillating electric and magnetic field, but EM waves we can produce by oscillating charged atoms. We can produce charged atoms. So this option is also incorrect. So the answer for this question is A.